Okay, here we're given part A. A function g of x equals the absolute value of x minus 2. And the function in part B is h of z equals z plus 1 over z minus 2. So we don't have to always use f and x. We can use whatever letters. Here we're asked to find for each of these functions the domain of each of these functions. Okay, now since we're looking at the first one, since the absolute value of any number is always going to be valid, it doesn't matter what number you put inside the absolute value bar, the answer for the absolute value will be a valid number. There is no restriction on the x value. It's because any x value we choose gives us a valid answer for the absolute value. Okay, so the domain of G is the curly set bracket, all real numbers x, such that x equals any real number. That's because we put no restrictions on x. In interval notation, that would be open bracket, negative infinity to positive infinity. Open bracket. Any real number. Okay, it's not going to be so easy for the next part, part B, because there will be restrictions on our domain z in this case. So we have h of z equals z plus 1 over z minus 2 for part B. And they're asking, find the domain of this function. Okay, so I want you to be careful here. Be careful because this is a rational function. In other words, it's a fraction. And you know you cannot have a zero denominator. No zeros in the bottom of a fraction. So we're going to get rid of all the z values that could potentially give us a zero denominator. How do we do that? We do it by setting the denominator z minus 2, that's the bottom of the fraction, setting it not equal to 0. And we're going to solve for z, and that will be the z that we cannot use in our domain. Okay, so to solve for z, we're going to add 2 to both sides to move the 2 over. We get z is not equal to 2. That's the result of adding 2 to both sides. Z is not equal to 2. Great. That is the nasty z value that gives us a zero denominator. So we're going to throw that away from all other possible z values, and that will give us our domain. So the domain of h is equal to curly set bracket, all real numbers z, such that z is not equal to 2. Now, how would you write that in interval notation? It's kind of hard to see. You might want to graph it first so you can see what it looks like. It has 2 parts to it. It's only missing the 2, the positive 2. So it's got the left side, that's the open interval from negative infinity to positive 2, open interval, union together with open interval from 2 to positive infinity, open interval. So we have open brackets at the negative infinity and the positive infinity because those are not real numbers. They always get open brackets. But we have open brackets on the 2 on the left and the 2 on the right because that indicates we're not including 2. That's the big hole that's missing. That's the only real number that's not included in the domain of h.